Alright, hello everyone and welcome again. So in the last video we learned how to find the area between two curves. So in this video what I'm going to do hopefully is to solve 3 examples depending on the length of the video. Okay, right, here's the second example in my handout. So we need to find the area of the regions enclosed by these two functions. So the first thing that I recommended is to draw these two graphs, right? So if you draw g 3x minus 8, that's how it looks like. If you draw f 10x minus x square, it's gonna look like this. I'm not the best artist in the world, so again bear with me. Okay, so this is 10x minus x square. So they're asking you to find the area between these two curves, right? Okay, now next thing you want to do is you want to find these intersection points. That's the next step as I taught you in the last video. So intersection points means the points where these two functions meet, right? So you equal them to each other and solve for x. So let's see. I can kick these terms into the right. So it's going to be x squared 3x minus 10x minus 7x minus 8 equal to 0. Okay, if I move around stuff. Now I'm going to factor this. So if I factor this, I'm going to get x minus 8x plus 1. So that means that x is equal to 8 and x is equal to negative 1, these two functions meet. So this left point is negative 1, the right point here is 8. That's where these two functions meet. Okay, so then we can set up the integral easily. Remember, we are integrating from now negative 1 to 8, and we just take the difference of two functions, top function minus bottom function. The function on the top is 10x minus x square minus the function on the bottom is, make sure to have parentheses, okay, so that you don't mess with the sign here, negative sign. So top function minus bottom function, that's how you set up the integral to find the area between two curves. Okay, right, so these are notes from the previous video, so let's erase them and try to figure out the answer here. Right, so let's simplify this before we integrate. So it's 10x minus x square. If you distribute the minus sign, minus 3x plus 8. Now, if I combine stuff, 10x minus 3x is 7x minus x square plus 8. So this is what we need to integrate. So if I integrate here, 7x, if I integrate, I'm going to get 7x square over 2. If I integrate x square, I'm going to get x cube over 3. If I integrate 8, I'm going to get 8x. Now I have to evaluate them at 8 and negative 1 and subtract. So let's do that. So here, if I substitute 8 square is 64. So 64 over 2 is 32. So this is 32 times 7. Okay. Minus 8 cube over 3 plus 8 times 8, 64. That's what you get by substituting 8. Minus, now you need to substitute negative 1. Negative 1 square is 1, so this is 7 over 2. Negative 1 cube is negative 1, so this is plus 1 over 3, because that negative and this negative plus 8 times negative 1, negative 8. Now you have to simplify these two to get the answer. So if I simplify, I'm going to get 121.5. That's the answer. I'm not going to show you the simplification, but I'm going to show you the answer so you can check it by yourself. So this is what I get. Okay, right. So that's one example, right? Let me do another example. Here's the second example. So find the area A of the region enclosed by the graphs of e to the x, gx is equal to square root x, and lines x is equal to 0 and x is equal to 1. So if I draw this, so e to the x, we know it looks like this, square root x, something like this, and then x is equal to 0 line means here you go, x is equal to 0, and x is equal to 1, so x is equal to 1, that's this line. So you want to find the area enclosed by these 4 things. So that means this area right here. So the area between e to the x and square root x and these two lines, x is equal to 0 and x is equal to 1. Now here, the good thing is you don't need to find the intersection points, right? So they have given you the left and right bound. So it's much easier. So you are integrating from 0 to 1, right? You want to find the area between those two limits, between the functions, the function on the top is e to the x, function on the bottom is square root x. So this is super easy. Now if I integrate this, I'm going to get, if you integrate e to the x, it's e to the x. If I integrate x, square root x means x to the half. So if I integrate that, I'm going to get x to the 3 over 2 times 2 over 3. Okay, and you have to evaluate from 1 and 0. So substitute 1. So e to the 1 minus 2 over 3, right? 1 to the power 3 over 2 is 1, right? Minus, now substitute 0, e to the 0 minus, if you substitute 0 here, everything is 0. So this is e minus 2 over 3, e to the 0 is 1 minus 1. So this is e minus 5 over 3 unit squares. Okay, so that's the area. Okay, so that was an easy problem to solve. Right, so here's the final problem that I'm going to do in this video, and then after that we will kind of tackle some different problems in these topics. Okay, right, so here they have given us the function x square, so I'm going to draw x square, and then 2 minus x. So 2 minus x should looks like something like that. So that's the 2 minus x line, and this is the function x square. So first thing you need to do is to find the intersection point. Now here you have to find intersection points because they are not given here, unlike the previous problem. So you make these two equal, x square equal to 2 minus x. So take these terms to the left. So x square plus x minus 2 equal to 0. So if I factor them, I'm going to get x plus 2, x minus 1. So that means these two curves intersect at negative 2 and 1, right? So here this is 1, that means this is negative 2. And that's all what we need to set up this integral, right? So we are integrating from negative 2 to 1. The function on the top is 2 minus x. The function on the bottom is x square, right? So you subtract these two. So you're finding the area in between these two functions, right? So now it's just integrating, right? If you integrate 2, you're going to get 2x. If you integrate x, you're going to get x square over 2. If you integrate x square, you're going to get x cube over 3. You are evaluating it at 1 and negative 2 and subtract. So let's do this. So if you substitute 1 first, so it's 2 minus 1 half minus 1 over 3. That's what you get when you substitute 1. Minus, now substitute negative 2. 2 times negative 2, negative 4. Negative 2 square is 4. 4 over 2 is 2. So it's minus 2. Minus 2 cube. Negative 2 cube is negative 8. So this negative and negative 8 over 3. So it's positive 8 over 3. Here. Right. So this is 2 minus 1 half minus 1 over 3. Here negative 4 minus 2 is minus 6. And with this negative, it's plus 6 minus 8 over 3. So now 6 plus 2 is 8. Negative 1 over 3, negative 8 over 3, that's negative 9 over 3 minus half. So 8 minus 9 over 3 is 3 minus half. So 8 minus 3 is 5. 5 minus half is 9 over 2. 4.5 or 9 over 2. So that's the answer. Unit squares, of course, because we are finding the area. So yeah, that's the answer to question 4. Okay, so it's relatively, hopefully, a simple idea. Okay, sketch the two graphs, find the intersection points if they are not given to you, and then set up the integral. So you are integrating from the left point to the right point, and then you take the difference between the two functions, where you subtract top function and bottom function. Okay, in that order. Right. So that sounds relatively simple. But now in the next video, we are going to look at how we might need to change the way we do these problems based on some tough problems. Okay, some different problems. So let's check that out in the next video.